Over here on the 12th of April, Marian Monday, you guys will be able to define and identify parallelograms and find their measures. Section 8.3. So 8.3 parallelograms. This is a special type of shape we're going to learn, okay? So we took those first two sections and talked about polygons in general, okay? After talking triangles for literally 3 months, okay? So parallelograms is going to be a special type of quadrilateral. We're actually going to take a deep dive, these next 3 sections, the last 3 sections of this chapter, into quadrilaterals, okay? To 4-sided figures. We're going to talk special quadrilaterals. So the first special quadrilateral is parallelogram. It is a quadrilateral. How many times can I say quadrilateral in like a minute, you know? With both pairs of opposite sides parallel. Does that make sense given the name? No. Parallelogram. And saying, hey, both sets of opposite sides are parallel. And we see that marked by our arrows here. Remember, arrows means parallel, okay? So can somebody give me a pair of sides that are parallel here? Example, side this and side this, or segment this, segment this. Liam.
AD and BC.
Okay, very good. Segment AD, or side AD, and segment or side BC would be parallel. Now, how do we know that segment AD is not parallel to segment BA, besides the fact that they touch?
They touch. It has those line thingies. It has the line thingies.
The arrows don't match up, right? They both have arrows, but one has 2, one has 1, right? That's different. Okay, who can give me the other set of parallel sides here? Jacob.
AB and DC.
His side AB and side DC would be parallel as well, right? Then we could switch those sides around, say DC or CD as well, okay? Naming parallelograms, just like we named triangles or we named other polygons, we could pick a vertex and we go clockwise or counterclockwise from there. Now, you can write out parallelograms so they get 4 of them, or you can draw a mini parallelogram, just like we drew mini triangles to save ourselves time. So, what is one name we could do for this parallelogram?
ABCD.
ABCD. What is a different name we could do for this parallelogram?
ABB.
I heard it?
ADCB.
Cool, and I said I heard it, but really, could there be a lot of different combinations?
No, yes, only those 2.
Oh, only those 2. Yeah, there could be really a ton of different combinations, right? Okay, actually a total of 8 combinations. Because you have 2 combinations for each vertex you start at, and there's 4 vertices. 4 times 2 is 8. Okay, so that's the definition of a parallelogram. A parallelogram means that both pairs of opposite sides are parallel. They're never going to touch. Bless you, bless rains down after, let's forget. Did we say anything about the angles? No. Did we say anything about right angles, stuff like that? Or opposite side lengths? No, we didn't say anything about lengths, didn't say anything about angles. We just said opposite sides are parallel. Now, we do have some theorems we know about parallelograms to be true, okay? So a quadrilateral is a parallelogram. What's this IFF? Does anyone remember that way back from chapter 2? If and only if. If and only if. Meaning that's a biconditional, meaning it goes both directions. So what that means is the normal part is true as well as the converse is true as well, okay? So both the converse and the regular are going to be true for these. So a quadrilateral 4-sided polygon is a parallelogram if and only if the opposite sides are also congruent. Meaning, if you see a quadrilateral and the opposite sides are congruent, you know it's a parallelogram, even if the parallel sides aren't marked. If both pairs of opposite sides are congruent, that's enough to know here. So, give me an example of 2 congruent sides here, Aiden.
AB and CD.
Very good. Side AB would be congruent to side CD, and I can mark that. Somebody give me another pair of congruent sides on this parallelogram.
ACBC.
Okay.
No.
Okay, Gage.
AD and BC.
Yeah, side AD and side BC. Now, realistically, it doesn't matter whether I put 1 tick mark on the left and right or 2 tick marks on the left and right. I just have to have them different from the other combinations, right? Because we're not saying all 4 sides are congruent, are we?
No.
Okay, it's possible they could be, but we're not saying that. It could be, doesn't have to be. All right. We also know that opposite angles are going to be congruent as well. So angles that are opposite from each other. So who can give me a pair of opposite angles that would be congruent? Kaya. Okay, angle A and angle C would be congruent to each other. So we can mark that on our picture here. And do they even look like they should be about the same? Okay. Aiden.
Upside down 7, B, upside down 7.
Yes. Angle B and angle D would also be congruent. I'm going to put 2 arcs in there since we listed the second there. So we could say that as well. So if you have a parallelogram, any quadrilateral with both pairs of opposite sides parallel, we automatically know the opposite sides are congruent and the opposite angles are congruent. If you have a 4-sided figure, a polygon, quadrilateral, opposite sides are congruent, it's a parallelogram. So the sides have to be parallel. Same scenario, quadrilateral, opposite sides are congruent, has to be a parallelogram. Has to. So these go both directions. If you know one, you know the other. Does that make sense? Okay. Gucci. So, knowing this information, we can find x and y on number 1. On number 1, does it tell us anything about how the sides relate to each other lengthwise or how the angles relate to each other measure-wise?
No.
No, but it does tell us what type of shape is this. Can we figure out it is? Parallelogram. So if it is a parallelogram, what do we know about those opposite sides? They're congruent. So could we figure out what y is? Yeah, we set up an equation. Now this one would be a very, very nice one-step equation, right? 12 equals y minus 6.
Yep.
So what's y?
18.
Okay. Now because it's a parallelogram, what do we know about the opposite angles B and D?
They are the same.
They are congruent as well. Okay, they're going to be the same measure. So we set up another equation. 64 is equal to 2x. So what's x?
32.
32. Questions on that? Okay. What? I'm just practicing my punches.
That wasn't a punch, though.
Yes.
Yeah, what?
No, it's the ultimate.
Wait, can you demonstrate 90-degree rotation?
Oh, yeah. Oh, sure. Oh. All right. Next, we have another theorem. If a quadrilateral is a parallelogram, then consecutive angles. What does it mean for angles to be consecutive again? Right next to each other. Okay, nope. Okay, they're adjacent, right next to each other. Yep. Okay. Consecutive angles are going to be supplementary. What does supplementary mean? Add it to 180, okay? Again, Ken. All right. So what are 2 angles here that would add up to 180 that would be supplementary? B and C. Cool. Measure of angle B, measure of angle C. Kai, what would you have said? Cool, that would work as well. Measure of angle A plus the measure of angle, you said D? Okay, would be 180 as well. Pick any 2 consecutive angles, and they would add up to 180. We could 180 degrees. You're right. Okay, we could talk about a couple ways why this would be true. Because it's a parallelogram, you then have 2 parallel lines cut by a transversal, right? So those then become same-side interior angles or consecutive interior angles, meaning they're supplementary. You do that with the other pair of parallel sides here. And say the same thing. Okay, Gage.
Also, we know that it has to add up to like 360 total.
Yep.
So both of those sides have to be 180.
Yeah, so what we can do there is we can say, okay, let's say angle A is x. Well, that makes C x as well, right? Let's say D is y, that makes B y. So we know if we take 2 times x, both those x's, plus 2 times y, we get 360, correct?
Yes.
Well, we learned from our one quick crash course about factoring that one day, my goodness, that was a big day, okay? That if we factor out a 2 out of both 2x and 2y, we can call this a 2 times x plus y. Now, the reason that works is because if I were to distribute back in the 2, do I get what I started with?
Yes.
Yeah, so I can take the 2 out. Now, if I were to divide both sides by 2, because I can do that now since I'm multiplying by 2, I get x plus y equals 180. So that's mathematically why it works. Which is what Gage was saying essentially just without the math terms behind it. Okay. Example 2. Yes. Okay, example 2. I want you to find x and y. All right. Number 2, how can we figure out x?
Magic.
It's the opposite.
Opposites of the congruent.
Yeah,
Opposite
they're
angle
congruent.
theorem. That I
Okay, how can we figure out y?
What consecutive is equal to 180, so 60.
Very good.
Wow.
I guess we don't even need the degree symbol there.
The opposite.
If you don't need the degree symbol, you could put it.
I did.
Question on that?
No, I'm not gonna say it.
Cool. Another theorem. Lots of theorems today. Whew, this is our 4th theorem already.
What?
We're cracking through these. It is. Okay. A quadrilateral is a parallelogram if, and only if, the diagonals bisect each other. What does it mean to bisect? Cross how? In the middle. They cut each other in half. Okay? Cut each other in half. Dissect is just cutting. Bisect is cutting in half specifically.
My hips don't lie.
So why are you covering your face?
Because that's how you do
Because
it.
his face lies.
It gets better hip movement.
All right.
Wait, are you
So
recording that?
fun fact about hips don't lie. So my buddy and I, we would play. We love playing volleyball together, and I'm like okay at volleyball. He's pretty good, and so we would play we'd go to the Corner State games down in Lincoln, and we'd play doubles volleyball together. And we'd play in the rec division. Don't get us wrong, okay? And so we're like, oh, let's just go play some grass doubles. So we played it a couple years in a row. Team name both years. Hits don't lie. Had to do it to him. So, we got second one year.
Good job.
Yeah, I have my medal. I still have my medal. Yeah, thank you.
Word loser.
Were you
That's true.
setter or was he
Well, in doubles you're both,
setter? Okay.
but I do it a lot more.
I can think how
so-
that works.
Yeah.
I always played volleyball.
Yeah. Well, so I mean, this is going to be in the video now, but so doubles is a lot different because your strategy changes a lot with where you're set up, and so you're both defense, you're both setting, you're both hitting, all of that stuff. You're both serve receive, and so it just really depends on who's able to get there first, and then whether you want to go get it over in 2 hits or in 3. So if you get it over in 3, it's always going to be whoever got the dig.
Yep.
Would be whoever's hitting, and then vice versa. Or if you're doing a 2, it's just immediately if you're able to get a dig into a hit.
Question. Dig when it comes over the net and you're like,
Yes. Yep. That's exactly right. Yep. So the dig is when you basically are receiving whatever they hit on the other side. Yep.
Doesn't mean it goes over.
doesn't the ball have to come over the net before you're tight?
Oh, I thought you meant after the game.
Yeah. Yeah, Aiden. Can I coach volleyball? Do I? No, I don't coach volleyball. I could probably coach a middle school level of volleyball. Would probably be the extent of my knowledge, and that would be stretching me.
We could do it, boys. You
But
guys
I don't think you
I'll be
could do
goated.
Oh my God.
What?
Liam, just
Very
throw
limited.
me out there.
I would. That's why I say middle school volleyball would stretch me. That's for sure. I'd have to study up more on them. I know the basic concepts of that,
Did you do that element?
but although I am a qualified line judger, I will say. So I've line judged volleyball games here for a few years. So
You're not supposed to say it.
yes. So
You do that.
You just do the thing, and you do it right.
You do the
You
thing.
just can't do this.
Why not?
Yeah.
That's part of the list.
yeah.
I have said the second part of many lists in his day.
Let's go.
Full of you.
You can use your feet in volleyball.
Yes, you can.
Yeah,
Yeah,
I
that-
learned that today.
No, you know, I learned that after I went to go pick it and it didn't.
Yeah. All right. Continuing on. So the diagonals bisect each other. So here, for example, the diagonal A to B, A to C, A to B is not a diagonal. A to C, this diagonal, is cutting in half the other diagonal. So D to B is being cut in half by the other diagonal. So that means D to E, segment DE, is going to be the same length as what?
Segment BE.
BE. And you see those marked there with being congruent. Now, this diagonal, DB, also cuts the other diagonal, AC, in half. So they cut each other in half. So that means A to E is also congruent to what? C to E. Hence the 2 tick marks.
Easy, not C.
Doesn't matter.
Oh, it doesn't matter. Could be either. Don't die on that hill.
Either or.
What? No.
We're done.
All right. So, do we see us potentially using that on example 3 here?
Yeah.
Oh, what a coincidence that we're going to use something right after we learned it. Okay? So, we know it's a parallelogram here because we have these very bold arrows marking that. Okay? And we see these diagonals. So we know the diagonals will bisect each other, cut each other in half. Gauge, don't do that. Okay? So if we know the diagonals are bisecting each other, we can mark them to be congruent. Each part to be congruent to the other part of the diagonal. Does that mean all 4 parts are congruent to each other? No, not necessarily. It could happen, but it's the exception to the rule. So what's one equation I could set up here to find x or y? Okay, Gage.
12 equals 3x plus 6.
Very good. What's the other equation I could use to find y?
2y plus 9.
Yes, 2y plus 9 equals 27. I set congruent things equal to each other. Have we been doing that for a long time in this class? Yeah, set things up that are congruent, equal. Okay. So we solve these equations. First equation, subtract 6. 6 equals 3x. And x is what? 2. Okay. So the next one, we subtract 9. 2y is equal to 18. What does y equal to? 9. Question on that. All right, we covered a lot of stuff about parallelograms today. Like, boom, boom, boom. Okay?
There's only 3 things.
It is all things. Like, I could look at the
4 things.
Oh, that is
What's the 4th one?
All right, parallelogram overview. What's one thing we know about opposite blank? Opposite blank or blank, opposite blank or blank, opposite blank or blank, consecutive blank or blank, diagonals blank each other. Someone give me one of these, okay? Kaya.
Opposite angles are congruent.
Cool beans. Opposite angles are congruent. Let's mark that on our picture. Okay, someone give me another one of these blanks. Check out.
opposite sides are congruent.
Opposite sides are congruent. Let's mark that in this picture.
We got side to side.
Okay. Aiden, you have another one?
Yes, diagonals bisect.
Diagonals bisect each other. Let's mark that in our picture. I'm going to do a different color for that. Notice I'm having to go up to 3 and 4 tick marks because I've already used 1 and 2. Okay, we have 2 more blanks. Dominic.
Opposite line segments are parallel.
Okay, I'll say opposite sides, but yes, opposite sides are parallel. Same idea, right? Line segments and sides, we're saying the same thing there. They're parallel.
Oh, parallel.
I so spelled that wrong.
Yep.
How do you spell parallel?
Well, with 30 minutes for
Do the thing.
Oh,
Like that, Bill. Parallel.
I spelled that so bad.
Seth.
Consecutive angles are supplementary.
Consecutive angles are supplementary. There's nothing we can really draw for that one. That's okay.
She does that.
Okay, how about clean?
No.
Okay.
Yes.
Questions on any of
I
that?
like that. And then I don't have
So, this overview, do you see this might maybe being a good spot for you to go back to in your notes later?
Yeah.
I'd say so.